So here we have a GitHub repository for a full stack web application that was developed for the performance of analysis jobs, create, read, update, delete, and other simple analysis jobs on a provided time series dataset. So the stack was developed primarily using Python um, and was packaged up into a Docker container for the deployment on a Kubernetes cluster living on an HPC machine that was provided by the Texas Advanced Computing Center. The container can be accessed through this link to the user's Docker Hub profile. So with it being deployed on a specific cluster, it's not intended for general purpose use, but we'll go ahead and run through um, what went into the development of this application. So we see here the directory tree. So we have a config folder where the Redis persistent volume claim was configured. We have a docs folder that contains instructions for the user and developer to effectively use the application or develop and deploy the application. Um, we have a source files directory with our Python source code and our input files. And then also in this base directory, we have our Dockerfile recipe for building the container from the source files. Um, and we have our YAML configuration files that define the properties of the microservices, including the Flask API, persistent volume claim, Redis as services and deployments. So we can go ahead and start with take a quick look at the config folder. So we have configuration file. I'm not going to run through all of this, but essentially this is a recipe for spinning up a Redis database instance. If we look at our source files folder, we have three modules. The first API.py. So this contains the Flask API app definition with synchronous routes that can be used to perform those CRUD operations on the provided time series dataset. So we see here we have instances of specific routes with like get and post methods for setting and retrieving data from the database. The source files directory, you also have a module called jobs.py, which contains the base functionality for working with the jobs in Redis. So the way this is done is a hot queue instance is instantiated and associated with the Redis service that's deployed in the cluster. And then you initialize a Redis object um, and attach that to the service. And then we have our essentially our job functions, so like generating IDs associated with jobs before they're set in the queue, returning job parameters, saving jobs, actually adding those jobs to the queue, returning job data, and then updating the statuses as those jobs are pulled from the queue. And then we have this module called worker.py, which actually contains the source code used to execute the jobs. So this is pretty bare bones, but essentially we have our custom analysis job, generate plot, that the user can interact with the application to effectively generate a time series plot of the dataset. And that plot is effectively um, copied over from the instance of the image or container running locally onto the user's machine through that persistent volume claim. Then if we look back at the base directory, we can see that we have a Docker file here with our recipe of instructions for copying our local environment into a Docker container so it can be deployed agnostically. So we have routines for specifying the Python interpreter that the code has been tested on, effectively copying our source code into that environment, specifying the working directory, um, running some installation commands to spin up packages that are needed to perform those, to enable those synchronous endpoints and perform those analysis jobs. And then we have our YAML configuration files. So we have 2 for the Flask, we have 2 for Redis, and then we have our worker and persistent volume claim. The most important one is going to be this prod Flask deployment configuration file, which you see here down under containers. This is where we specify the name of the Docker container that the stack is containerized into. So it goes by the name prod Flask here. Final prod project production. And then we're specifying some commands to that are executable from the container once it's run. So we're going to want to be able to run our API module and just make it easy on their user. And then we're characterizing our environment, specifying like the IP address for the Redis instance and our port binding. So if we look here under my repository, so I have a Docker Hub repository for this project with the same name as that image that we looked at in the configuration file. So final project prod, just have a brief description of what this container is used for, and a brief repository overview. So again, the user would navigate to this repository, run a Docker pull command to pull the container to their local machine before running. Now again, this is not something that is intended for general purpose use because it was tailored for being deployed in a specific Kubernetes cluster on a particular HPC machine. So this is not something that a user would be able to reproduce at this time. However, when this project was actively maintained and updated, that was the process to go about interacting with the application and running analysis jobs.